Assalamu alaikum everyone. Today we'll start problem 4.2. Let's see the statement of this problem. Find the perpendicular components of a force of 50 Newton making an angle of 30 degree with x-axis. This is the line for x-axis. The force is making an angle of 30 degree with the x-axis. The magnitude of the force is 50 Newton. We have to calculate the perpendicular components of the force. The perpendicular components of the force are, there are two perpendicular components of the force. The first one in the x-axis direction, that's called f of x, and the second component is in the y-axis direction. That is called fy. To find f of x, we know that f of x is equals to f multiplied by cosine of theta. And to calculate the f of y is equals to f sine of theta. So f of x should be equals to 50 Newton f into cos 30 degree, 43.3 newtons. And to calculate f of y, the component of the force in the y-axis direction is equals to 50 Newton multiplied by sine of 30, which is equals to 25 Newton. Let's see the statement of problem 4.3. Find the magnitude and the direction of a force if its x component is 12 Newton and y component is 5 Newton. In this problem, the f of x, the component of the force in the x direction, is equals to 12 Newton, and the component of the force in the y direction is equals to the 5 Newton. Here we have to find the resultant force F, its magnitude, and its direction, theta angle. To find the magnitude of the force, we use the Pythagoras theorem, where f of x square plus f of y square under root should be equals to the magnitude of the force. As you know that if force was acting at some angle theta, the mutually perpendicular components are always makes 90 degree with one another, f of x and f of y. So let's take this projection of f of y to complete our triangle here. And this will give rise you a right triangle. So a right triangle, in this right triangle you can apply the Pythagoras theorem to calculate the hypotenuse value. If you know the value of perpendicular and the value of the base of the triangle. So the base square plus perpendicular square under root of that should be equals to the length of the hypotenuse. So this relation can be used here to calculate the resultant of the force. So F is equals to 12 square plus 5 square, and it should be equals to 169 under root, and under root of 169 is equals to 13 Newton. Now to calculate this angle theta, where the resultant force is acting, we can again use the relationship of the trigonometry. As we know that the tangent of theta is equals to perpendicular divided by base, and theta is equals to tangent inverse into f of y over f of x, which is equals to, as f of y is equals to 5 divided by 12, and taking the tangent inverse of this ratio, we will get 22.6 degrees. So in 4.3, if the perpendicular component f of x and f of y are provided, you can calculate the magnitude of the resultant force by using the Pythagoras theorem, and you can also calculate the direction of the resultant force by using the trigonometric relation tangent inverse f of y divided by f of x. Let's see the problem 4.4. A force of 100 Newton is applied perpendicularly on a spanner at a distance of 10 cm from a nut. Find the torque produced by the force. Before starting this numerical, let's see what is the torque. Torque is a turning effect of the force. And what is the turning effect of the force? The turning effect of the force is called the moment of the force, or simply you can say torque. Moment act about a pivot. Here in this figure, you can see a nut is tightened in a clockwise direction. The nut is pivoted. The pivot point is the point where a body is fixed and rotate about that point. Moments act about a pivot in a clockwise or in an anti-clockwise direction. So when a force is applied and a body is start rotating about a fixed point, this is called the turning effect of a force. The turning effect of force is simply called torque. Larger the force, larger the turning effect, and larger the moment arm, the distance between the pivot point and the application of the force, as it can be seen in this figure in the red dotted line, the moment arm, larger the moment arm, larger the torque will be. So the moment of a force or a torque is determined by the product of the force and its moment arm, L. Mathematically, torque is equal to force multiplied by L. Now we have to enlist our given data. As we know, the force is equals to 100 Newton and the distance of 10 cm from the nut. This is our moment arm, that is L, which is 10 cm. In all these numerical, we have to use SI units, System International Units. So 10 cm is not the SI unit. To convert it into the SI unit, we have to divide it by 100. So 0.1 meter. This is the SI unit of length. To calculate the value of torque, torque is equals to force multiplied by the moment of 100 Newton multiplied by 0.1 meter. Newton meter. When a force of 100 Newton is applied by the spanner on a nut from a 10 cm distance, it will tighten the nut with the torque of 10 Newton meter. To open this nut, to loosen this nut, you have to use the same torque. That's all about today's problems. If you understand this problem, share my video, like my video, and subscribe my channel. Thank you.